Chapter 4-7, the quadratic formula. Quadratic formula is another method used to find the solutions or the x-intercepts of a degree of 2. So the formula is derived by completing the square and solving for x. It's used to find the x-intercepts or the zeros of a polynomial of degree 2. Give them polynomials in the form of ax squared plus bx plus c. This is going to be your formula. And yes, you're going to hear me sing all the time about this because if you sing it, you remember it. So it actually goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So pop goes the weasel, right? Kind of cool. So you're going to hear me sing it all the time. It's going to be something you're going to be annoyed at. It's going to be stuck in your head forever. But you'll remember it, okay? This will let you factor anything that you absolutely have that is degree 2. But the kicker is it has to be in this form of ax squared plus bx plus c. If it's not, you can't use the formula. So, discriminant. Discriminant is the junk underneath the square root. It's the part of the quadratic formula that is underneath the square root. And what does this part do? It determines the types of solutions you'll have. There are going to be 3 types of solutions you can have. Okay? The first one is if b squared minus 4ac is greater than 0. If it's greater than 0, then you have 2 real solutions. Those 2 real solutions are either going to be a rational number, meaning fraction, or an irrational number, something with a square root in it. Okay? But b squared minus 4ac has to be greater than 0. Rational if the value is a perfect square. Irrational if the value is not a perfect square. Rational meaning square root of 49, square root of 64, square root of 25. Those are all going to be numbers that are perfect squares, so therefore it's going to be a rational outcome. Irrational would be like the square root of 17, the square root of 24. Even if you reduce that, you're still going to get a radical in the expression, so therefore it's going to be irrational. Okay, well what happens if it's equal to 0? Well, if it's equal to 0, then you're going to have one double root. A double root means that you have 0 being in your discriminant, meaning it can't do anything. It doesn't affect the problem, okay? And then our last one is going to be what if it's less than 0? Well, if it's less than 0, clearly you cannot take the square root of a negative number. Because if you take the square root of a negative number, that means we're in the imaginary number system and you have to put negative 1 times whatever. And what's negative 1? I squared. So what do these things look like visually? If b squared minus 4ac is greater than 0, you're going to have either rational or irrational, meaning you can visibly see where they are crossing the x-axis. You can see it. You can see that they're crossing. If it's a double root, or meaning it's going to be one solution, meaning this is going to equal 0, it touches the x-axis at one point, and then it shoots right back up or it shoots right back down. And if b squared minus 4ac is less than 0, again, we're trying to find x-intercept. If it's imaginary, can you see it crossing the x-axis if it's an imaginary number? No, because it's either going to be above the x-axis or it's going to be below the x-axis, meaning it's never going to cross the x-axis, which therefore means it's imaginary. So that is what it's going to look like visually for you. So if I give you a picture of something that looks like this, you can immediately tell me that the discriminant is going to be what? It's going to be greater than 0. Why? Because you can visibly tell it crosses in 2 places. If I give you something that looks like this, you can visibly tell it's only going to be crossing at one spot, so therefore b squared minus 4ac is equal to 0. And if I give you something that looks like this, you can clearly see it's never going to cross the x-axis. Therefore, what type of roots do you have? Clearly, if it's not going to cross it, that means it's going to be imaginary. If it's going to be imaginary, the only way you can get an imaginary root is if it's less than 0, meaning you have a negative underneath the square root. So let's actually apply this concept. Use the discriminant to determine the types of solutions you will have. So what I have to do is I need to make sure that this is in the form of ax squared plus bx plus c is equal to 0. And clearly you can see that it is, so I need to pull out my a, b, and c values. A is going to be what's attached to the x squared, which is going to be negative 2. B is going to be attached to what's to the x, which is the negative 3. C is going to be what's attached to no variable, which is going to be just a 5. Now that I have a, b, and c, I'm simply going to use the discriminant. The discriminant is going to be b squared minus 4ac. B squared in this case is going to be the negative 3. A is going to be negative 2, and c is going to be 5. Negative 3 times negative 3 is 9. A negative times a negative makes it a positive. 4 times 2 is 8, times 5 is 40. So 9 plus 40 is going to be 49. Is this number going to be greater than 0, less than 0, or equal to 0? Well, if I'm comparing that to 0, you can clearly tell that 49 is greater than 0, which means I'm going to have 2 real roots. More specifically, what type of roots are there? Well, I need to look at 49. And then you need to ask the question, is 49 a perfect square? If you say yes to that, that means it's going to be a rational number. If you say no to that, then that means it's going to be an irrational number. Since 49 is a perfect square, meaning 7 squared, then this is going to be rational roots. Meaning you're going to be able to see them. They'll be 1/3, it'll be 7, it'll be 6, it'll be 1/2. You'll actually know what they are. Okay? Let's do it again. Use the discriminant to determine the types of solutions you will have. Well, is it in the correct form? Well, the correct form is ax squared plus bx plus c is equal to 0. And yes, it is. So immediately you need to pull out A. A is -4, B is 20, C is -25. And I'm going to go straight to my formula, which is b squared minus 4ac. And b is going to be 20 squared minus 4 times -4 is a, times c, which is going to be -25. Well, 20 times 20, well, what's 2 times 2? 4. Tack on 2 zeros, so that's going to give you 400. Negative times negative times a negative is a negative. And 4 times 25, 4 quarters is $1, so that's going to be 100 times 4 gives me 400. And 400 minus 400 gives me 0. What is the relationship between 0 and 0? They are equal to one another, so therefore this is going to be a double root. Meaning, what does that look like graphically? It touches and it shoots right back up, or down. In this case, it's going to be down. Why is it going to be down? Because A is negative, meaning it's reflected. Okay, that's the discriminant. Now, how do we actually use the quadratic formula? Well, if we're going to use the quadratic formula, what this means is you have to first put it in the form that we can use it, which is going to be ax squared plus bx plus c is equal to 0. So in order to use this, I'm going to bring over this lovely little 25. So if I do that, the next thing I want to do is I'm going to pull out a, b, and c. A is attached to the x squared term. There's nothing there, but there is a phantom 1, which is supposed to be 1 there. B is going to be 10. C is going to be 25. And I am going to bring out my lovely little quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So that is my quadratic formula, so I plug in what I know. What's b? 10, but it says negative b, so that's going to be negative 10 plus or minus. What's b again? That's going to be 10 squared minus 4. What's a? 1. What's b? 5. All over. Do you see that? All over 2 times a, which is going to be 1. So all you're going to do here is simply calculate. Bring the negative 10 down, plus or minus. 10 squared is 100, minus 4 times 5 is 20, all over 2. So I have negative 10 plus or minus. 100 minus 20 gives me 80, all over 2. And I'm going to freeze, because this number tells me something. B squared minus 4ac, that's going to give me 80. 80 compared to 0 is what? Greater than, so I'm going to have real roots. And in this case, is 80 a perfect square? No, it is not, so therefore I'm going to have irrational roots, meaning I'm going to have a square root left over, aren't I? Since I'm going to have a square root left over, I need to go ahead and finish this and calculate it. So negative 10 plus or minus, well, 80. What are some perfect square factors of 80? Well, let's think about that. What's 16 times 5? Well, 6 times 5 gives me 30. Carry the 3. 5 times 1 is 3, plus 5 times 1 is 5, plus 3 gives me 80. So this is going to be 16 times 5 over 2. The square root of 16 comes out as a 4, so I have negative 10 plus or minus 4 square root of 5 over 2. Now, because these three numbers are all divisible by 2, I can reduce this. So negative 10 divided by 2 gives me negative 5. 4 divided by 2 is going to give me 2 square roots of 5. Here are my two answers. So if I ask for my x-intercepts now, I have negative 5 plus 2 square root of 5 comma 0, and negative 5 minus 2 square root of 5 comma 0. And there's your lovely little x-intercepts. Let's do it again. Solve using the quadratic formula. Is this in the form of ax squared plus bx plus c? Clearly not. I have parentheses, so I need to get rid of those parentheses. So I'm going to distribute. That's 4x plus 2. Now I'm going to bring everything over to one side. So I'm going to subtract the 4x and subtract the 2 from both sides. By doing that, I now am in the form of ax squared plus bx plus c. So now I need to find a, b, c. A is 3, b is negative 4, keeping that sign to the left of it, and c is negative 2, again keeping that sign to the left of it. So I need to use my quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. You're going to get sick of hearing it, but it's going to be there every time. So I plug and chug into my formula. B is going to be negative 4, so I have a negative times a negative 4. Make sure you do not drop that, okay, so that you understand that it's there. Negative 4 is going to be B. I'm going to square that. Minus 4. A is 3, and C is 2. All over 2 times A, which is going to be 3. So I continue calculating. A negative times a negative is a positive 4. Negative 4 squared gives me 16. A negative, I only have one of them, so it stays. 4 times 3 is 12. 12 times 2 is 24. All over 2 times 3, which is 6. Now what is 16 minus 24? That's going to give you negative 8 over 6. Again, I'm going to freeze, and I'm going to analyze this. My discriminant, which is b squared minus 4ac, is equivalent to negative 8. Now what is the relationship between negative 8 and 0? Negative 8 is less than 0, which means I'm going to have imaginary roots, which means it's going to look like something like that. It's never going to cross the x-axis anymore. Okay? So I need to reduce this, though. So I'm going to have 4 plus or minus. That's going to be negative 1 times 4 times 2 over 6. 4 plus or minus I squared times 4 times 2 over 6. I squared comes out as a I. 4 comes out as a 2. So what do I have here? It's going to be 4 plus or minus 2i square root of 2 all over 6. So again, I do not look at the square roots. I look at the jump on the outside of the square root, and I say, do all of those numbers have something in common? And the answer to that is yes, they do. They all have a 2 in common. 4 over 6, that 4 divided by 2 turns into a 2. 6 divided by 2 turns into a 3. And 2 divided by 2 turns into a 1i. So I have 2 plus or minus I square root of 2 all over 3. So my x-intercepts are going to be 2 plus I square root of 2 over 3 comma 0, and 2 minus I square root of 2 over 3 comma 0. There's your x-intercept. That's all the notes for today. Please make sure you've copied everything down. Go to Edmodo and answer the questions that I will have there. Tomorrow in class, we will work on the worksheet together.